Welcome back. In this session, we are drilling down into the fundamental building blocks of your Cloudera data platform network on AWS, the subnets. We will move beyond the VPC level to understand how to segment your network for security, high availability, and proper service discovery. Let's get started. Let's define what we are working with. A subnet in AWS is essentially a subdivision of your VPC's IP address range. Crucially, while a VPC spans an entire region, a subnet is locked to a single availability zone, or AZ. This physical constraint is vital for CDP. When we deploy a cluster, we place its nodes into these subnets. By distributing subnets across different AZs, we ensure that if one physical data center fails, your CDP environment can continue running in another. Think of subnets as the specific rooms inside the house of your VPC where your actual servers live. Visualize the hierarchy here. At the top, we have the AWS region housing your VPC. Inside the VPC, the architecture splits into distinct availability zones, shown here as AZ-A and AZ-B. Notice that Subnet 1 is strictly contained within AZ-A, and Subnet 2 is strictly within AZ-B. They do not cross over. This separation is the foundation of fault tolerance in CDP. Not all subnets are created equal. We categorize them based on their routing. A public subnet allows traffic to flow directly to and from the internet via an internet gateway. In CDP, we strictly limit what goes here, typically just load balancers and NAT gateways. In contrast, a private subnet has no direct path for inbound traffic from the internet. However, nodes here can still reach the internet for updates by hopping through a NAT gateway. For a secure production environment, your data lake and data hub worker nodes must always live in these private subnets to reduce the attack surface. Here is the traffic flow. The public subnet at the top connects directly to the internet gateway, allowing two-way traffic with the internet. The private subnet below, where your data lives, is isolated. To get out, it must route traffic through the NAT gateway residing in the public subnet. This one-way valve architecture ensures your data remains secure, while still allowing necessary updates. What is the ideal layout? Cloudera strongly recommends a 3x3 topology. That means creating 3 public subnets and 3 private subnets. You should map these pairs across 3 different availability zones. Why 3? Many distributed systems, like the consensus protocols used in CDP services, require a quorum to survive a failure. By spreading across 3 zones, you ensure that even if one entire AWS data center goes offline, your data lake and enterprise services remain operational. This diagram illustrates the resilient 3x3 design. We have 3 columns representing availability zones 1, 2, and 3. Inside each AZ, we pair a public subnet with a private subnet. This balanced distribution guarantees that we have redundant capacity in every failure domain, protecting your critical data workloads from regional disruptions. Let's talk about capacity planning. IP exhaustion is a common pain point. When you define the sitter block for your subnets, go big. For data lakes and data hubs, we recommend a /19 sitter to accommodate the VMs and databases. For data services like Cloudera Data Engineering CDE or a ICML, remember that they often require their own dedicated subnets and consume IPs for every pod and node. A /24 is the absolute minimum, but sticking to /21 or /20 is safer to handle auto-scaling spikes without running out of addresses. Here we see a VPC carved up into subnets of different sizes. On the left, a large /19 subnet provides over 8,000 IPs, ideal for the heavy footprint of data lakes and hubs. On the right, a smaller /24 subnet provides only 256 IPs. While sufficient for small, isolated services, notice how quickly it could fill up. Always verify your service requirements before locking in a small sitter. How does traffic know where to go? Route tables. A subnet is only public if it is associated with a route table that points internet traffic 0,0,0,0/0 to an internet gateway. Conversely, a private subnet's route table must point that same traffic to a NAT gateway. A common mistake is creating the gateways but forgetting to associate the route tables with the subnets. Without this association, your private nodes will be completely cut off from the world, unable to download software updates or communicate with Cloudera control plane. Follow the logic flow. A subnet is tied to a route table. The critical decision happens at the target step for the default route 0,0,0,0/0. If the target is an internet gateway IGWA, the subnet becomes public. If the target is a NAT gateway, the subnet becomes private. This simple configuration determines the security posture of everything inside that subnet. For modern data services running on Kubernetes, like CDE and CDW, networking goes beyond just IP addresses. It involves discovery. You must tag your subnets so Kubernetes knows where to place load balancers. On your private subnets, you must add the tag Kubernetes, eo/role/internal elb with a value of 1. On public subnets, use Kubernetes, eo/role/elb with a value of 1. If these tags are missing, service creation will fail because the cloud controller won't know where to provision the ingress points. This flowchart shows the discovery process. The Kubernetes cloud controller scans your VPC resources looking for specific tags. If it finds the internal ELB tag, it successfully deploys a private internal load balancer. If it finds the ELB tag, it deploys a public load balancer. But if no tags are found, the path leads to failure, stopping your service deployment in its tracks. To wrap up, let's review the golden rules for AWS subnets in CDP. First, strictly enforce isolation by keeping workloads in private subnets. Second, ensure high availability by adopting the 3x3 topology across 3 availability zones. Third, prevent scaling issues by over-provisioning your sitter ranges. IPs are cheap, rebuilding VPCs is expensive. Finally, always verify your tags to ensure smooth service discovery for Kubernetes-based applications. This final visual summarizes our strategy. The core subnet strategy branches into 3 pillars: security, achieved via private subnets; resilience, achieved via multi-AZ architecture; and scale, achieved via large sitter blocks. Keeping these 3 pillars in mind will ensure a robust CDP deployment.